Okay, so I'm Radu. I work at Sematext. I'm a search consultant there. I mostly work with Elasticsearch. And I'm also working on a tool that's about aggregating logs, which is called Logzine. I'm co-authoring a book called Elasticsearch in Action. And when I don't work, I match shoes with my wife and my son. So centralizing logs, when you have a bunch of applications and they're logging to whatever they're logging, and the goal is to be able to do real-time search and analytics on that data. So reports, statistics, visualizing, whatever. And the way I'm going to look at it is to ship all that data into Elasticsearch and to get to do the visualizing and the searching with Kibana. So first, why Elasticsearch? I think it's kind of important to have indexing, to index your logs so you can do that searching and analysis in real time, and Elasticsearch lets you do that. And so, yeah, you sacrifice a bit of write speed because you have indexing, but write speed isn't really that bad, and I'm going to talk about it in a bit. Also, you have lots of tools that can already work with Elasticsearch to ship your logs there. And I think the reason for that is because you have quite of a straightforward REST API. So you send your logs in JSON to Elasticsearch, you get a JSON reply back saying, hey, I've indexed your logs. And the same thing goes when you search. You get your search goes in JSON, and you get a JSON reply back with the results. And another cool thing about it is that it scales by default. So if you just start an Elasticsearch node and you start pumping data into it, by default you're going to get your first index partitioned into 5 shards. And if you start a second node, it's going to discover the first one via multicast, and the 5 shards are going to get replicated once. And then after you add more nodes, those 10 shards are going to get automatically balanced across the whole cluster, which I think is really cool. So, but that only gets you, well, not so far away. And I'm going to say a few things that should help you get your Elasticsearch cluster work nicer with logs in terms of stability and performance. So the first thing is discovery. Discovery is how nodes communicate to each other and form a cluster. And by default, this is done by multicast. And if you stick with this, you should really change the default cluster name. Because if you don't, anyone who just pops up an Elasticsearch node will join your cluster. And you might not want to have that done. If you are on an environment that doesn't allow multicast, like EC2, there are plugins that allow kind of the same behavior of dynamic discovery, let's say, in those environments. And if you're paranoid like me, you can just use unicast and define a list of nodes in each of the nodes configuration, so you have a more, let's say, static cluster. Once you have the cluster running, you want to make sure that it remains one cluster. So you don't want to end up in a split brain situation where some nodes cannot communicate with others, and then you end up with 2 clusters and you'll have a hard time putting all the data back together. So the way, something that helps with that is to set a minimum master nodes of at least half the total number of nodes in your cluster. And that means a cluster is formed only if at least half of those nodes can communicate to each other. So that if a bit of your cluster is left out, it won't form another cluster, and this is what we want. Then there's memory. You don't really want to run out of it. And the rule of thumb is allocate half of your RAM to Elasticsearch and leave the other half for OS caches. And if you want to tune it further, you have to monitor how much memory Elasticsearch actually uses. And then you can tune the setting accordingly. We actually have a monitoring SaaS called SPM, and one of its flavors is for Elasticsearch specifically. You might want to check it out. And if we zoom a bit more into memory, there's this special cache called field cache, and that is used mostly when you do stuff like sorting and facets, when you do analytics. And because it caches like your actual data, the fields that you have, it's kind of expensive to build. So the default is that this field cache gets resident memory and is unbounded. So that might blow up your memory. And so a way to prevent that is to make to change the cache type from resident to soft. And that means the garbage collector will be able to reclaim some of that memory if it becomes, too much. What I prefer to do is to just limit the field cache to to a slice of the total memory, and this is possible if you have like Elasticsearch 090 or above, which you should. Okay, on to performance. The single best thing you can do for performance is to make sure that your logs get shipped into bulks instead of just one by one. Many tools do that by default, like Logstash, for instance, but it's worth checking out like how big your bulks actually are, because if you have lots of info and you have big nodes, you need bigger bulks. And there's also a bulk UDP API. I'm not aware of anyone that actually uses it, but I thought it's just really cool because it works really fast. And then there's some batch operations that are done within Elasticsearch. So when you index something, it first goes into the transaction log and then gets indexed into memory. And every once in a while, this transaction log, the data from it gets flushed into the actual Lucene index. And this is according to some thresholds, which you can adjust. And again, if you have a lot of data coming in, you might want to up those thresholds. Then there's refresh. Refresh is an operation that makes newly indexed data available for search. And this is quite an expensive operation. And by default, is done every second. And what you might want to do is to increase this 1 second interval to some more, however more you can afford, in order to get more indexing throughput, because you'll get less load. Then, because logs are timestamped, it's nice to put each interval of logs in its own index, which leaves you with like a hot index there on top. And the good thing actually there are three good things about this, is when you're indexing in a small index, that's much faster than indexing in a bigger one. When you search, you typically search only in recent data. So again, that will be faster. And then when it comes to deleting, it's much faster to just expire entire indexes, to delete them, instead of deleting individual documents from within an index. The flip side of this is, when you search in all the logs, Elasticsearch will have a tougher time aggregating the results coming from multiple indices. So you want to make sure that you don't end up with a lot of those time-based indices. And again, some tools already do that by default, like Logstash. And finally, some more buffers and caches. There's an index buffer that you might want to up if you have a lot of indexing going on. And then, if you're on a 64-bit machine, which you probably are, using mmapfs as the sort type will get you, it will make better use of OS caches for when you index and for when you search. Okay, let's move on to Kibana. Once you have your data in, which I'll talk about in a minute, you can use Kibana to do the searching and the visualization. And the cool thing about Kibana 3, this latest version, is that you can put it on any HTTP server, and then because it's only HTML and JavaScript, your queries are run from your browser directly to Elasticsearch. So there's no actual backend there, which is really cool. And for searching, you have quite a lot of options. Actually, Kibana is having these dashboards which you can customize, and you can do a lot of visualizing. And one of the things I want to mention here is that in order for this statistics and visualizing to work, is you have to have, for example, here there's a pie chart with file extensions. For that to work, you need to have those file extensions really in its own field in the JSON document that you push to Elasticsearch. So it doesn't work if you just have like these unstructured events that you just slash in there. I want to talk a bit about syslog. Who has to deal with syslog here? Can I have a show of hands? Oh, quite a lot. Okay, so syslog is kind of a mess, because when you say syslog, first you don't know what the other one's talking about. So is it a syslog daemon? Is it a message format? Is it a protocol? And there's many of each. So first let's talk about daemons. There are three major ones. One is syslog-D, which is the kind of traditional, old-school one. Who has to deal with this, with syslog-D? Okay, so quite a lot. And then there are the modern ones, which syslog-ng and our syslog. They're slightly different, but I really want to stay away from flame wars. So our syslogs, I'm more interested in it because it has this Elasticsearch output. But this is, by the way, who has to deal with syslog-ng and our syslog? Okay. So, was my curiosity. So the cool thing about these two is that they have modules, and they're really fast, and they have lots of features, but I'm going to talk about them. So the modules are pretty much, you have an input module that will get data from your devlog, but can also tail files and whatever not. Then you have some parsing modules, which can not only deal with syslog formats, they can parse JSON, which I'll talk about in a minute, and they can also parse unstructured data and put that into variables that you can later assemble into whatever documents you want. And then you have output plugins that can tail files and other stuff. But let's move to the syslog format. This is kind of what you think of when someone's, this is what I think of when someone says the syslog format. And this has been around since the 80s. But it was documented in 2001 in something that people refer to as a standard, but it's not really a standard. It's like let's document what the status quo is. And it has quite a lot of problems. The timestamp is pretty crappy. You're limited to 1K. Okay, you have a bit of a structure in the sense that you have a priority, a timestamp, a host, a program name, but everything after that is just free text. And you typically send them via UDP. You can also send them via TCP, but when that happens, you can't send multi-line messages because messages are delimited by a new line character. So if you want to send a stack trace, it will end up in multiple messages. Thankfully, there's a new format, as in 4 years ago, new format. It is a bit more complicated, but it solves all those problems. So you have an ISO timestamp, you have no theoretical size limit, you have a place for structured data, and there are separate RFCs for sending messages over UDP, over TCP, over TLS. And what's cool about each of those is that you can send multi-line messages. Now the problem with this is it's not so widespread. So okay, syslog-ng and our syslog support this format for a while now, but syslog-d doesn't, and a lot of the tools, a lot of the libraries that can write to syslog don't support this format. So you kind of have to do some hacking every once in a while. And our syslog does a few of those hacks. For example, you have a pattern, and it also accepts this sort of messages, where you just have the old format, but you put the ISO timestamp instead of the crappy one. That works with our syslog. You can also send these messages via TCP. That at there means send over TCP. And if you put that O into parentheses, it means octet count framing instead of the new line delimiting, which lets you send multi-line messages. With both our syslog and syslog-ng, you can configure the limit of how big of a message can be. And last one is this thing, which actually works everywhere. It works with every tool and every daemon. In that free-formed message part, you can just say @CE, because CE is the name of the standard, and then you can slap a JSON there. And as long as you don't bump into any other limits, you can just send those messages, and if you have further down the road a syslog-ng or an rsyslog, then they can parse this JSON, and you can use templates to modify it for example, what I do is I take this JSON, I take all the data that's outside of it, like a timestamp, priority, host, and whatever not, and put it inside the JSON, and take that bigger JSON and put it into Elasticsearch as a document. And finally, TCP isn't enough for some people, so there are actually protocols that provide application level acknowledgement. Unfortunately, there's no standard for that, so each of those has its own protocol, which sucks, but is better than nothing. But for encryption, at least, there is a standard which works with both. Okay. Let's talk about Logstash a bit. Logstash is mostly like those two syslog daemons in the sense that you have inputs, filters, and outputs, and you have plugins for any of those. The difference is there are lots of each. I wanted to put all of them on the slide, but then I thought, it's going to be, characters are going to be like this. So the cool thing about those is you have lots of plugins. It means you can set it up in different ways. The simplest way is you just, on every host that's logging, you can put Logstash and make it send your logs to Elasticsearch and parse them along the way if you want to. But Logstash is quite big in terms of how much memory it uses. So sometimes it makes sense to use Lumberjack to put it on your host. Lumberjack is a small tool that's written by Jordan Cecil, the guy who also did Logstash. And it's really tiny. It can tail files and listen to standard input. And it can forward those messages to Logstash over its own protocol, which is reliable, as in application level acknowledgement, and encrypted. And then you can have Logstash parse those messages and send them over to Elasticsearch. The problem with this setup is that you don't really have a buffer. Logstash doesn't really do that. So what you can do is put a Redis in the middle. So you will have a Logstash that receives the logs and the Logstash that indexes the logs. The cool thing about this setup is that you can scale everywhere. So you can have multiple receivers, and you can configure Lumberjack to have like an array of destinations. So if one Logstash goes down, you will use the other one. You can scale Redis, and you can also have multiple indexers. And you can also scale Elasticsearch. And if we add syslog and Kibana to the equation, we have like what we started with. And this is what we're trying to do with Logzine. We expose the Elasticsearch API so we can work with Logstash and any other tool that can output to Elasticsearch. We also accept syslog in lots of formats and protocols. And you can use, in addition to our own UI, you can use Kibana as well. But if you want more alternatives, you might want to look into the Solr ecosystem. Solr is, much like Elasticsearch, is an open source search engine that's distributed and based on Lucene. There are some differences, and again, I'm going to try and stay away from flame wars. If you want to go with Solr, you'll probably want to use Apache Flume. Apache Flume is much like Logstash in the sense that it has inputs, filters, and outputs. All are plugins, but they're named differently. And it was initially done so you can ship your logs to Hadoop. Now it also supports Solr as a destination. But the trouble is I didn't really find a good alternative to Kibana in the Solr ecosystem. But that's the cool thing with open source, is that you can mix and match. So for example, Flume can already output to Elasticsearch. I've heard of a project called Kibana for Solr, so someone's probably porting that. I also plan on working on a output plugin for Logstash that outputs to Solr. So you can really use like whatever you want. And I think that's cool. Thank you. Do we have some time for questions?
Yeah.
Okay. Are there any questions? No questions?
When you're playing your syslog directly into Elasticsearch,
Yeah.
are you logging that into a different index to the Logstash, getting Kibana to read both, or are you putting them into the same index?
Okay, so the question was if when you plug syslog directly to Elasticsearch, if I put them in the same index as Kibana, as Logstash or another index. Well, you can do any of those. I personally don't use Logstash in production, so I don't do that actually. But you can do either of those. You can configure whatever index you want to use. So does that answer your question? Yeah. Okay. Any other questions?
Thank you, Radu.
Do you have any more time? Because I have some extra slides.
Yeah.
I can bore you even more. Extra slides. I'm gonna talk a bit more about syslog in case you didn't hear enough. So I'm gonna talk. I have 4 slides just to show you like some of the things you can do to make your rsyslog really fast. So some people claim like 1 million messages per second and stuff like that. And the first thing to do to achieve that is to upgrade your rsyslog. They provide RPMs and some Ubuntu packages, and that, in addition to better performance, you'll have a new configuration format. Actually, it's also backwards compatible, but you have like a new one with ifs and brackets and stuff. And you also have the Elasticsearch output module, which is cool. On the indexing side, on the receiving side, if you use UDP, you probably want to increase that time requery thing, which tells rsyslog how often to pull for the system time. And if you use TCP on Linux, there's this module done especially for Linux, which is much faster, called IMP TCP. The standard one is IM TCP. And then it's all about queues. There's the main message queue in which logs that you get are gathered, and you can, and this is where all the hard work is done, like parsing. So you can choose whether you want that queue to be in memory, on disk, or in some sort of a combination. Of course, in memory is the faster way. And you can choose the size, and you can choose the size of your batches, because those messages are processed in batches, and it's the same thing all over the place. If you have lots of messages, you probably want bigger batches. And you can configure the number of threads that you want to work on this queue. And then there's the action queue, which serves the action, in this case, the Elasticsearch output if you're using it. And usually you don't have to worry about this that much because it's not much happening. It's only the messages get assembled and forwarded. But with our syslog, it's a bit of a special, with Elasticsearch, it's a bit of a special case in the sense that you have a bulk of messages, you send it over, you wait for it to get indexed, and then you get the reply, you parse the reply, and then you move on. So this is why it makes sense to have a queue here and to have more than just one thread if Elasticsearch can handle the amount of logs. And now I'm really done.